பண்ணால் எப்படி இருக்குமோ அந்த மாதிரி ஒரு ஃபீலு. என்ன சொல்கிறதுன்னு தெரியல, நிறைய பேசணும். ஒரு சின்ன ப்ரெசன்டேஷன் இருக்குது. அந்த ப்ரெசன்டேஷன் பண்ணும்போதே வந்து சில இன்புட்ஸ்லாம் உங்களுக்கு ஷேர் பண்ணுறேன். பட் ஃபார்மலாக நான் வந்து கொஞ்சம் வெல்கம் பண்ணுறேன் உங்களை. ரெஸ்பெக்டட் சிஇஓ ஸ்ரீ சாய்ராம் குரூப் ஆஃப் இன்ஸ்டிடியூஷன், சாய் பிரகாஷ் லியோமுத் சார். அண்ட் லியோமுத்து சார் நம்ம கூட இல்லைனாலும் நிறைய அவரோட விஷனரி தான் இன்றைக்கி வந்து இந்த காலேஜ் இப்படி நிற்குது. அதில் நானும் ஒரு ஸ்டூடெண்ட்டுன்னு நினைக்கிறதுல எனக்கு ரொம்ப பெருமையாக இருக்குது. அவர் ஒரு விஷனரி. ஸோ என்னோடய இன்ஜினியரிங் வந்து இங்கே தான் தொடங்குச்சு. பட் அதுக்கப்புறம் வேறு மாதிரி லைஃப் இஸ் டேக்கன் அ ஷேப். ஆனால் பேஸ் வந்து இங்கே தான் உருவாச்சு. அஃப்கோர்ஸ் டிப்ளமோ இன் மெக்கானிக்கல் இன்ஜினியரிங்கும் எனக்கு பேஸாக இருந்துச்சு. இந்த ரெண்டு காலேஜும் என்னால் மறக்க முடியாது. அதுக்கப்புறம் சொல்லணுன்னா அது இங்கே வந்திருக்க எல்லா டிஸ்டிங்விஷ் இன்வைட்டீஸ்க்கும் என்னோட வாழ்த்துக்கள். அதுக்கப்புறம் என்னோடய காலேஜ் நான் கிளாஸ் படித்த ஸ்டூடெண்ட்ஸும் சில பேர் வந்திருக்காங்க இங்கே. குமரப்பன், ஸ்ரீகிருஷ்ணா, அதுக்கப்புறம் ராஜேஷ், சில பேர் நான் பார்த்தேன். இன்னும் எவ்வளோ பேர் இருக்காங்கன்னு எனக்கு தெரியல. மேபி இந்த ப்ரெசன்டேஷன் முடியும் போது அவங்களையும் மேடையில் கூப்பிட்டு இன்ட்ரடியூஸ் பண்ண நல்லாயிருக்கும்னு நினைக்கிறேன். அப்புறம் என்னோட சொல்லிக் கொடுத்த டீச்சர்ஸ், அதை என்னால் மறக்க முடியாது. ராஜேந்திர பிரசாத் சார், அவர் வந்து ஹெச்ஓடியாக இருந்தாங்க நான் படிக்கும்போது. அவரோட இன்ஃபேக்ட் ஒரு இன்டர்வியூ கூட வந்து எங்கள் ராக் கைஸ் குரூப்னு ஒன்று இருக்குது. அதில் பார்த்திங்கன்னா நிறைய மெசேஜஸ் போயிட்டே இருக்கும். அதுதான் நான் ஸ்ட்ரெஸ் பஸ்டராக யூஸ் பண்ணுவேன் எப்பப்பெல்லாம் எனக்கு ஃப்ரீ டைம் கிடைக்குதோ. அதில் வந்து ராஜேந்திர பிரசாத் சாரோட வீடியோ வந்து நிறைய திரும்ப ஃபார்வர்ட் பண்ணிட்டே இருப்பாங்க. அவர் நம்ம சத்யாவை பற்றி பேசினதை வந்து ரொம்ப ஃபார்வர்ட் பண்ணிகிட்டே இருப்பாங்க. அது எனக்கு ரொம்ப பிடிச்சிருந்துச்சி. அப்புறம் சொல்லணுன்னா விஜய் ராம்நாத் சார், அவர் அப்போ லெக்சரராக ப்ரொஃபஸராக இருந்தாருன்னு நினைக்கிறேன். இப்போ ஹெச்ஓடியாக இருக்கார். அப்புறம் மேனேஜ்மெண்ட்டில் வந்து சார் பேர் எனக்கு மறந்துருச்சு. அப்புறம் அன்பரசு சார், அவர் என்னோட ஹாஸ்டல் வார்டனாக இருந்தார். தமிழரசன் சார், சாரி அன்பரசன் கிடையாது, தமிழரசன் சார், அவர் என்னோட ஹாஸ்டல் வார்டனாக இருந்தார். அந்த மாதிரி கொஞ்சம் பேரை நான் பார்த்து ரெக்கக்னைஸ் பண்ண முடியுது. இன்னும் நிறைய பேர் இருப்பீங்க. நான் மேபி இந்த ஃபங்க்ஷன் முடியும் போது நான் மீட் பண்ணுறேன். பட் இந்த மாதிரி ஒரு விழாவை வந்து நான் இதுவரையிலும் பார்த்ததே இல்லை. எப்போ பார்த்தாலும் ஒரு சின்ன ஒரு வட்டத்திலே வந்து ஒர்க் பண்ணிக்கிட்டே இருந்தேன். இதை எனக்கு ஒரு மாதிரி ஒரு டிஃப்ரெண்ட்டான ஒரு ஃபீல் இருக்குது. நான் ஒரு சின்ன ப்ரெசன்ட், ஏன்னா கோபிநாத் சாரும் இருக்கார். அவர் வந்து உங்களெலாம் வந்து என்னை வந்து பேசணுன்ற மாதிரி அந்த மாதிரி ஒரு ப்ரோக்ராம் பண்ணணுன்ட்டு அவர் நினச்சிருக்காரு. ஸோ அதுக்கான டைம் நம்ம நிறைய தரலாம். ஒரு சின்ன ப்ரெசன்டேஷனோடு நான் முடிச்சுக்கிறேன், ஒரு 15-20 மினிட்ஸு. ஏன்னா நான் இங்கே வந்தது வந்து என்னென்னா, நிறைய பேர் சம் இன்ஃபர்மேட்டிவோட நீங்கள் வென் யூ கோ ஹோம் யூ ஷுட் கேரி சம் இன்ஃபர்மேஷன்றதுனால நான் ஒரு ப்ரெசன்டேஷன் பண்ணேன். இது வரலும் எந்த இடத்துலையும் போய் பண்ணலை. சந்திரயான் 3 பற்றி நீங்கள் வீடியோ பார்த்துருப்பீங்க லேண்டிங் அப்போ. அது நீங்கள் ஜஸ்ட்டு ஒரு டிவிலையோ இல்லை யூடியூப்லேயோ பார்த்துருப்பீங்க. ஆனால் அந்த ஒரு 19 மினிட்ஸ் நடந்தது மட்டும்தான் உங்களுக்கு தெரியும். அதுக்கு முன்னாடி என்னென்னலாம் நடந்துச்சு, எதனால் அது சக்ஸஸ் ஆச்சு, அப்புறம் என்னென்னலாம் கண்ட்ரீஸ் நம்ம போய் லேண்ட் ஆகியிருக்காங்க, அதோட சவால் என்ன, இதை பற்றின ஒரு சின்ன ஒரு ப்ரெசன்டேஷன் தான். உங்களுக்கு எங்கேயாச்சும் போர் அடிக்குதுன்னா நிறுத்திடலாம். அதுக்கப்புறம் கோபிநாத் சாரோட ஷோவை ஸ்டார்ட் பண்ணிடலாம். ஸோ நெக்ஸ்ட் ஸ்லைடு போங்க. ஸோ these are the countries who have landed safely and softly onto the lunar surface. So you may be knowing that 3 countries have already landed. One is US, Russia and China. US 2 missions they had. First initially they had a Ranger mission, but Ranger mission they could not accomplish the soft landing. Then they went for a Surveyor was really a successful mission for US. And you all know that Apollo is a crewed mission, it's not a robotic mission. And finally the Russians also, you know, there was a race between US and Russia during those times. So USSR also had a soft landing technology, so they call it as a Luna mission. There are series of Luna missions which also landed softly and safely on the lunar surface. Then Chinese also, they had a mission, Chang'e 1, Chang'e 2, like that series of missions they had. First two missions was an orbiting mission. Then Chang'e 3 onwards, it was a soft landing mission. And as you all know, India, we had a Chandrayaan mission. First, Chandrayaan 1 was started with an orbiting mission. Then Chandrayaan 2, the objective was to have a soft landing. But you all know that we could not succeed the last phase of the mission. Hence, Chandrayaan 3 has begun. So, Chandrayaan 3 was soft landed. These are the various landing points in the moon it was landed. Ours was at 69.9 degree latitude towards south and 32.3 degree towards east. This was the target coordinate. Initially 10 years ago we have decided this is the point we are going to land, and accordingly we crafted our lander engineeringly. Whatever the requirements are there, we have captured accordingly. So that's how this point was selected. And see how complex is the landing mission. You people should know there are many unsuccessful attempts before the successful mission. So if you see US, they had 3 failures before the first successful mission. Russians also, they had 11 unsuccessful attempts before the first successful attempt. And India also had Chandrayaan 2 failure, and then followed by Chandrayaan 3 mission was there. And recently there were many unsuccessful missions. Beresheet is one satellite from Israel that also did not land. Second is Akuta R1 mission, that is Japanese mission. Japanese also, before to our landing, they could not successfully land. And just 2 days before our landing, Luna 25 from Russians. See, just I wanted to tell you, Luna, even though Luna, there are series of Luna who have demonstrated successfully in the past, but Luna 25 has got all new systems, but still they could not attempt. Just before our landing, they also targeted the landing coordinates just near to our Chandrayaan 3 landing coordinate, and they wanted to go and prove that they wanted to be the first towards lunar south pole. But unfortunately, they had a crash landing because of so many reasons which I am not going to tell. And just wanted to tell that the landing missions are very complex in nature. It's not like a orbiting mission. Orbiting mission means we have plenty of time to do, but landing you don't have any time. You have to build all the intelligence, and it has to take a real-time decision, and finally it has to be on its own for a landing. That is the main crux of the landing mission. Just before going the challenges, we should know the fundamental difference between the moon and earth. Earth, all of you know, the gravity is 9.81 meter per second square, whereas moon is having a 1/6 of gravity, which is 1.62 meter per second square. And diameter of the earth and moon, there is a variation, there is a difference. Mass also, there is a significant difference. And the rotation period, as you all know, earth rotates about its own axis. It takes 24 hours. So 12 hours is the day and 12 hours is the night. Whereas if you see the moon, it takes one revolution 24 days, and in that one lunar day is 14 earth days, one lunar night is also is equivalent to 14 earth days. And escaping velocity is this is something very, very important, because if you want to go to another planet, or if you have to have like a Voyager where you have to escape from our own galaxy, you require a velocity of 11.2 kilometer per second to inject an object which escapes from the Earth's sphere of influence. See, every planet has got one sphere of influence. We are all actually stuck here because it has its own gravitational pull. Similar way, if you want to go away from the Earth's sphere of influence, you have to transcend 9 lakh kilometers from the Earth's surface. So you require an energy of 11.2 km per second, whereas moon escaping velocity is very less. And surface temperature is another one important thing. See, Earth has got, because of atmosphere, we are all saved. Our temperature is, whether it is a day or night, not much variation you can see. Whereas moon, when sun is there, it goes to very high temperature of 120 degrees centigrade. When sun is not there, it goes to very low temperature of minus 150 to minus 175 degrees centigrade. So that is the kind of extreme temperature the surface experiences. And another important thing is there is no atmosphere in Earth, whereas in moon. In Earth we have atmosphere, we are all protected, whereas in moon it is a deep vacuum. These are the fundamental differences, and we have to craft the lander for this condition, and we need to carry out the test to meet these conditions. That is the major challenge for us before the landing. Next, and also Earth to Moon distance is 3.84 lakh kilometers. It varies from 4 lakh kilometer to 3.6 lakh kilometer to 4 lakh kilometer. It varies because Earth and Moon is not a circular orbit, it is an elliptical orbit. So you have to travel that much of distance to acquire the Moon. So that is how we designed these are the mission phases. You would have seen only the launch phase. The launch phase is also critical. Unlike other missions, we cannot launch every day or every month or every 15 days once. We have a specific window. During that time, the spacecraft has to be injected. That is the first challenge. Second challenge is we have several phases. See, you would have seen in the Twitter handle during our orbit raising maneuvers. Initially, whatever the launch vehicle has injected the spacecraft, further it has to be taken to a moon's orbit, that is 4 lakh kilometers. So we were taking a baby step because we have our own propulsion system which is very capability wise. Whatever the capability we had, we have to fire our own engines and then take it to the moon's orbit. This is how the orbital maneuvers have been performed. Next. So there are various challenges. So one of the first challenge, as I already told, launch is a challenge. Again, orbit raising is a challenge. Acquiring the moon is a challenge. All these things are challenge. But we have done already in Chandrayaan 1, 2, as well as 3 also we have done. But what is that we have not done is the last phase, that is 19 minutes of terror. Because we have already, Chandrayaan 2 we did not successfully land. And failure was not an option for us. But at the same time, success also did not come easily. So we crafted the lander meticulously to adopt the situation that whatever the path it takes, it has to land. That was our target. So towards that, as I told, there is no atmosphere in moon. So we have to have our own propulsion system to descend, and it has to kill the velocity. So you just imagine you are taking off from the Sriharikota with a 0 meter per second velocity, and you have to attain orbital velocity, Earth orbital velocity for reaching the moon's orbit. Then again you are reducing the velocity. Finally you have to land with 0 meter per second. So you have to kill the velocity without having any atmosphere. At least if atmosphere is there, we can use parachute so that you can reduce the velocity by drag. But here it is not possible. We have to use an active propulsion system. So we use the chemical propulsion system to kill the velocity, nearly bringing down from 1.68 km per second to 0 meter per second. That is the first challenge. Second challenge is there is no GPS in moon. So we have to use our own sensors. We need to know that where are we, satellite where it is. Until you know that satellite position and velocity, you will not be able to go to the point where you want to go. So that is another challenge for which we added terrain relative navigation sensors. There are a host of sensors we developed, tested, and on board that sensors were there. Then the third one is the navigation system and propulsion system. All these 4 things have to work in unison, because if anything one is not working, other one we will have a problem. So everything has to work in unison. That is another challenge. Then finally, when we come to landing, there are so many obstacles. Those obstacles, it's an unknown terrain. When you go to an unknown terrain, you may topple. The module may get toppled. You may reduce the velocity, but you may get toppled. So to avoid that, we have to have an intelligence, or we need to have a sensor which actually it will sense the hazards and it will avoid the hazard so that you have a safe landing. So that is another one important thing. Finally, when we touch down, it has to absorb the energy. See how our legs are there. These legs are there. You cannot jump from 10-story building. You can jump from smaller height, so that our legs is capable enough to absorb the energy. Similar way, we have lander has got 4 legs. You would have seen this lander was, our Sairam Engineering College lander was landing. So this is what we wanted actually. This is what has happened also on that day. But we did so many other simulations to see that whatever the condition, we have to land. So for that, plenty of efforts have been put. So that is another important thing. The lux has to absorb the energy, and it has to kill it has to offer a stability platform. It should not topple. So that is also we have to do a test. Next slide. So as I told, to do all these things, we have to have a test setup to validate all these design, whatever I told, sensor, navigation, propulsion system, lander leg. There are many systems which I already told. All these things has to be thoroughly characterized so that we have a proper landing. For that we devised the various tests. One is we hired an helicopter and we created some artificial craters and boulders in Chitradurga area. We flew one more lander inside the helicopter and we tested like how we land. Similarly, we tested not once. There were many tests we have done. Second test is, having taken that sensors and navigation, we have also put propulsion system also. So that test we have done in Sriharikota because propulsion system is very hazardous in nature. So we have to do a test where it is, we have to do it in a conducive environment. The third test is the lander leg drop test where we have to absorb energy. As I told, the velocities it has to absorb, and you do not know whether it is a hard terrain or a soft terrain, and you also do not know whether it is a flat terrain, whether it is a slopey terrain. Under all the combinations we have to do a test. That is the third test. Next. So just for you to know that Chandrayaan 2, when we had a Chandrayaan 2 mission, Chandrayaan 2 also we did same thing. We launched in 2019. July 22nd it lifted off, and we had a series of earthborne maneuver, lunar-borne maneuver, and finally the orbiter and lander got separated. And also just before the landing, next slide, this all went well. The last stage, you can see in this graph, there is a red color line which is actually the expected trajectory. The blue dotted one is what we got on the day of landing. So you can see that the first phase went well, that is rough braking phase. The next phase we had a problem, there was a deviation, and the third phase it called for an aggressive maneuver. In that process we lost the altitude and we gained a very high velocity. That's why we had a crash landing. See, as I told, even the aircraft, whenever it is taking off or whenever it is landing, you have to have a smaller velocity for us to survive. Similar way, we ended up in Chandrayaan 2 with a residual velocity of 50 meters per second, which is way beyond our Chandrayaan 2 leg capability. That's why we had a crash landing. Next. So, having addressed this problem, what was the problem? We learned from the failure. Second is, we did a lot of simulations. There were many hundreds and hundreds of simulations we did. Then we devised a test. Whatever the test we could not do during Chandrayaan 2 time, we have overcome by doing additional tests. The third and fourth is the on-orbit characterization. Just before the landing, we were actually characterizing our propulsion system, sensor system, and so on. And finally, this only led us to safe and soft landing. Next slide. So there are various improvements because I am not going into the detail, but one thing I will tell, we had a multiple mission plans. If one is not going well, what is the next option? If that next option is not going well, what is the next option? Like that, whatever human mind can think, the failure scenarios, we addressed all those things a priori to launch. And we devised the various mission plans. For everything we had a contingency from launch till landing. That was our strategy during Chandrayaan 3 time. So that's why we had a confidence, not because that day we had a confidence, because of our 4 years of hard work where we crafted all the things, whatever can go wrong, and we did a test, and all this culmination only you are seeing that landing day was successful day. And also various other systems, even though ISRO's culture is, if one system does not work in the previous mission, we will look into all other systems and we improvise. That is our culture. So we did so many improvements in other systems as well. Next. And this I will not go into detail. Next slide. And our landing site point, this is our landing site. This is our landing site point. Even I was telling, we had an alternate landing site also. For example, 23rd August, if you would not have landed, we had an alternate landing site which comes in the west direction. Actually, we targeted east. The latitude, if you see 69.3 degree latitude south, and east we have chosen the prime landing site. In case for some reason we could not land on that day, so we would have actually landed 26th August with the west landing, even though the latitude, keeping the latitude same. So we had the various contingency plans in our Chandrayaan 3. Next. So some of the scientific instruments, I don't know, people may not be interested in this, but it is not only, our objective is not only to have a safe and soft landing. We also have an objective, scientific objective, because going to the moon is not only just to demonstrate the safe and soft landing and leave it there. We had scientific instruments to measure the temperature, thermal conductivity, and detecting the major rock forming elements, seismic activity, lunar plasma environment studies, electron density, electron temperature. There are various science aspects also it has got, for which we had state-of-the-art in situ surface experiments in both lander and rover. So the lander is very static in nature. Once you land, it will not have a wheel to move, whereas rover has got a wheels. So it has an advantage that at one point you study the surface of the moon and you can travel from one point to another point. Again you operate the payload and you study, and then so on. So it goes like that. So I am not going into each and every detail, but this is the basic purpose of post-landing scenario. Next. You can click the next arrow. See, just to give the photograph of our instruments, on the left side there are three modules. One is the propulsion module on top of it, and the center one is the rover, and the bottom one is the lander, and center one is the integrated module. This is how it was sitting inside the launch vehicle, and the launch vehicle has actually carried this spacecraft and injected. And the right side, whatever pictures you are seeing, the top one is one of the tests inside the helicopter, where we flew to the Chitradurga area. The center one is the test. It's an outdoor test. It's again a unique test, a new test bed. It's a creative test bed was created, and we have carried out a many tests. Then the bottom one is the lander leg drop test, wherein we dropped at an height and ensured that the strength and stability is maintained. Next. Just you can click this one video. You can come out of the presentation. One video is there.
The Chandrayaan 3 spacecraft consists of a propulsion module and a lander module, with a rover accommodated inside the lander. The propulsion module and the lander module are stacked together to form the integrated module. 6 modules were realized during Chandrayaan 3 project life cycle, out of which 3 were flight modules and 3 were special test modules, namely the integrated cold test, integrated hot test, and lander leg drop test modules.
The main function of propulsion module is to carry the lander module from launch vehicle injection till lander separation. The propulsion module was made ready for further integration with lander module.
A 6-wheeled rover is accommodated inside the lander, which would be deployed onto the lunar surface post-landing. integration test, rover standalone EMIMC test, vibration test, thermovacuum test, and mass property measurements were carried out. All tests associated to rover were successfully completed and the rover was made ready for further integration onto lander. After integration, detailed IST, sensor level alignment and EMI-EMC tests were also carried out before shipment to ASTE Bangalore. Realized at SDSC Shah for conducting the IHT, craters and boulders simulating hazards during landing. A total of 20 tests were successfully conducted, which include 6 dry runs, 8 static tests, and 6 dynamic closed-loop tests. The lander leg drop tests were carried out to evaluate the energy absorption capability, strength and stability aspects of lander legs during touchdown. A new facility was realized at iSite with a test bed with flat and 12-degree inclined drop surface. Detailed tests were carried out at damper level, single leg level, simulator level, and QM structure level for various touchdown velocities on flat and sloped surface and on lunar soil simulant and hard surface. A total of 15 drop tests at simulator level and 2 drop tests at QM structure level were conducted successfully. The objective of lander is to demonstrate safe and soft landing on lunar surface. Major elements of lander include sensors, after the completion of thermal elements in the rover compartment, the rover was assembled onto the ramp using 3 hold-downs. Detailed assembled mode IST was carried out, followed by mass property measurement, thermovacuum test, solar panel assembly and illumination test, EMI-EMC test at CATF iSite. This was followed by pre-dynamic deployment of secondary rover ramp, primary ramp and rover rollout from lander and payload deployments such as ILSA and Ramba, chased, and the lander was made ready for further activities. Once the lander module was ready, it was stacked over the propulsion module to form the integrated module. EMI-EMC, vibration tests, acoustic tests were carried out. Final finishing activities such as MLI sealing, Chandrayaan 3 spacecraft was made ready for shipment to spaceport at SDSC Shah.
You can go to the slide. Just 2 more minutes only I'll take. See, you have seen only the video visuals up to the spacecraft readiness and is shifted to the Sriharikota. Generally what happens, our satellites gets integrated, designed, developed and integrated at UR Rao Satellite Center, which is in Bangalore. After that, the satellite is transported via road to Sriharikota. Likewise, rocket also comes from Trivandrum and both gets integrated and launch takes place at Sriharikota. So you have seen only the satellite till the readiness at UR Rao Satellite Center. Some of the visuals, this is how the spacecraft was made ready and transported from the Sriharikota, and it is encapsulated and transported to the actual launch pad. Next slide. And this is how the launch took place. Next. And these are the various events which we already talked about. Next. And this is, you would have seen on the landing day, actual visuals coming from the one of the camera in the lander, which is partially taking the picture of lander as well as the moon surface. So this was coming every 3 seconds in that 19 minutes, throughout the 19 minutes from 30 kilometer till touchdown. And finally, we know the critical parameters we are seeing, but for the public, it's something seeing is believing. So we put one camera next, and this is very interesting picture. On the left side, you can see our Chandrayaan 2. Even though the lander has failed, but orbiter is still functioning. The designed life was one year. But it is now more than 4 years over, still it is functioning, it is going around the moon. And we had one camera, that camera is having a very high resolution, 0.32 centimeter resolution it has got, and this is the best available globally. Even NASA did not have that kind of a resolution, they had 0.5 meter, ours is 0.32 meter resolution, it is the best available. So the right side picture you can see, after the landing, the left side picture is before the landing, right side picture is after the landing. Our Chandrayaan 2 orbiter, which is orbiting at 100 kilometer orbit, has taken a picture of our lander. The next. And you can click this animation. Just click that video. So this is how you are seeing this is an animation. Upon landing, you have a ramp deployment. Then rover will be powered on because rover was in off condition till landing. And it establishes the communication between the rover and lander. And finally, see, now this is onboard camera. You have seen the ramp deployment, you have seen the rover also coming out of the lander, and it touched the moon, lunar surface. This is what has happened actually on the day. This was not shown to the public soon after the landing. We were working overnight to deploy the ramp and taking out the rover from the lander, and it finally touched the lunar surface. Next. This is something, this image we cannot forget. On the left side, you can see the lander sitting upright. See, all this time till 23rd August, we used to refer the publications from other spacefaring nations where they have landed, and they were having their own lander sitting onto the moon surface. First time we saw our own lander sitting onto the moon surface. This visual was taken by our rover camera, which is away by 30 meters. And rover has got a camera that has captured the lander, which is sitting upright. This really we got a goosebump during when we saw first time the lander sitting on the moon surface. And this is also on the right side, you can see the rover coming out of the ramp. We have our Indian flag. The Indian flag was captured. See, in the landing point area, since it is going towards, we are in the South Pole, near to the South Pole. The sun elevation angle is not like it goes top. Say for example, here 6 o'clock it starts sun rising in the east direction, and it goes all the way to 12 o'clock midday. It goes above our head, and again it settles at west direction. But in polar condition, you don't have that kind of a sun elevation angle. Maximum it elevates from 0 degree to 22 degree, which means even a small height it casts a long shadow. So during the shadow, when rover is coming out, partially it was shadowed. Then when it is coming out further, we saw that our flag, Indian flag, when it is coming out, that also was an important moment. And on the wheel, at the back side of the rover wheel, we had one Indian emblem, other one is our ISRO flag, ISRO logo. That also was captured by our lander camera. Next. And you can also see not only the lander, there are various payloads. As I was telling that there are scientific payloads, which also has to be inserted into the lunar regolith. Some things have to be deployed. One of the seismic activity is just we have to drop onto the lunar surface. All those things were done. Next. And this picture is, you see that yellow color, that is our Shiv Shakti point. This is how our PM has kept the name, where the lander landed. And rover has travelled from that Shiv Shakti point to various places. Almost 100 meter. Nearly 100 meters the rover has travelled within 9 days of time. Even Chinese, they have taken 120 meters for 6 months. So we have travelled in 9 days. We were operating continuously 24/7 during that time. Next. And this is, can you click the center picture? see, towards the end, we also did one more important experiment. We know that our mission life is only one lunar day. So anyway, we know that the mission is not there. So we took off from the place where we landed in an open loop firing and fired the same engine, and we landed slightly a hop-on experiment we did where we landed slightly away from the site where we have decided. By which what we have done is, you can click this link, center you can click. Just press the center button. So there is a visuals that you can see that the plumes are previous center. You can click the center. This is the visuals where the dust were coming. You can see suddenly the engines are fired and some dusts are coming. So this is how, because we don't have a rover camera to capture this event, but we fired. It gave an enormous confidence for our future sample return missions. So that also was proven. That way it exceeded our expectations. Next slide. These are the various things. Finally we soft landed. Next. So further details are available in the Twitter handle. If anyone is interested, scientific data and all is available. Next. So with this I'll end my presentation.